Hello everyone, I am Anand Srivastav. Today we will discuss one of the important branch of mathematics that is called set theory. As one time Galileo said that universe is a grand book written in a language of mathematics. So here is another branch of mathematics, set theory. Now, as we know that there are different approaches to solve a problem in a mathematics. You can say these approaches are called different branches of mathematics. One of those branches, set theory, is a branch. During study of infinite collection of real numbers, George Cantor gave path to study this branch. Now, it is a very important tool in a mathematics to understand the mathematical ideas in a very easy way. Now today we will discuss this set theory. Before discussing the set theory, we must know what is the set. As according to the Cantorian concept, Cantorian concept of set is a well-defined collection of distinct objects to be conceived as a whole. A set is a well-defined collection of distinct object to be conceived as a whole. Here there are many important words in this definition. First one, you see this well defined, another distinct, one is collection, and at the last conceived as a whole. Since set is also as a abstract concept, so at this level to understand the set we will overlook this part. So I am going to remove this part to be conceived as a whole. So now our definition of a set will stop here. So what is the set? A set is a well-defined collection of distinct objects. Now let us understand these three things. First one is collection. Second one is well-defined. And you can take second, distinct objects. So as from the word collection, you have collected something or making the group, that is the collection. So no problem in this collection word. Distinct, it is also clear from the word distinct, means they are different from each other. Means in a set there will be no repetition of the its members, and members are also called the elements of the set. So now onwards we will treat members as a elements of the set. In a broad way, you can think that set is a collection. Okay, so in that collection the members will be known as the elements, but in a mathematics the set is defined, the collection must be well defined. What is the meaning of the well defined here? For example, suppose I tell you to find the collection of 5 natural numbers. So 5 natural numbers if I give this statement to 40 students, maybe they can collect the different natural numbers. Suppose one student collected 1, 2, 3, 4, 5. Another may collect 11, 12, 13, 14, 15. So in that way, you can say this collection is not well defined. So to make it well defined, we can say first 5 natural. So we can say that first 5 natural numbers are, in that case, only this 1, 2, 3, 4, 5 will be the collection. So this is the well defined. Another example to stress on this word well defined, suppose I ask you, write the names of the best writer of the world. Write the names of the best writer of the world. So best writer of the world will be different for different persons. So if I, so this collection will not be well defined. Let us take another example. Write the names of the good students of your school. So as per the different students, the good students will be different. That's why, and if you say that write the names of the students who got more than 90% in a session ending exam. So in this case, our collection will be well defined. So I think now it is clear. A set is a well defined collection of distinct objects. From here we can see that a set, every set is a collection, but every collection cannot be set. I think from here it is clear the meaning of the well defined. Okay, now come to the another part of the representation of a set. Normally we represent a set by capital letters. A set is represented by capital English alphabets. Say A, B, C, X, Y, Z, etc. And the elements or the members of the sets are shown by the small letters. The members or elements will be shown by small letters. Example is small a, b, c, x, y, z, etc. This is the way to represent a set. Another, there are two types of showing a set. There are two types of representing a set. One is roster form, you can say it tabular form also. One is roster form and you can say tabular form also. Another is set builder form. So let us discuss these two ways to represent a set. In first way, what we do, we write the elements inside a curly bracket separated by the commas. For example, here I am going to write vowels of English alphabet. So it will be A, E, I, O, U. There are 5 vowels in English alphabet, so I will write in this way. And if I represent this as V, this can be written as E, I, O, A, U. Order does not matter. So you can write it any order. This is the one way to write a set, that is in a roster form or tabular form. The same set can be written using set builder form. Here we will have a builder for the set, means there will be a well defined characteristic followed by all the elements of the set. For example, I am going to write the same set. V can be written as X such that. This will be read as such that. This can be also written by this. X is vowel of English alphabet. So this is the another way to write a set. Let us another example. Suppose n represent natural number, so I am going to write natural number 1 separated by comma 2, 3, 4 and so on. Similarly, the natural number can be shown in the set builder form. Natural number x such that this, I am going to use this symbol here. X is a natural number. So this is another way to show the set. Now there is another way to represent the set, that is the by the help of Venn diagram. Actually, Venn diagram was given by John Venn in 1880 to represent the sets. Actually, this one is a pictorial representation of a set. Before going to say about this, I am let you clear that a set is an abstract concept. It has no look, but to understand it in an easy way, this John Venn has given a pictorial representation. In this, what we say, a set can be presented by any closed curve. Closed curve, preferably we take circles. So by the help of circles we show set, and if these circles are inside a rectangle, this rectangle will show about the universal set. Universal set is supposed to be to have all the subsets. So here in a Venn diagram there is no provision for showing empty set. We will just go on to discuss what is the empty set. Now there are types of sets. In types of sets, first is empty set. It is also called void set, or you can say null set. A set which has no element, not a single element is the member of that set is called empty set. For example, a set having no element. Example, this can be this is shown by 5 or simply showing the curly bracket. The set phi, we can say x as that x is even prime number greater than 2. So as we know that 2 is only even prime number, so there will be no element in this. You can also show another example, x such that x square plus 1 equals to 0. X belongs to R. It has also no solution, that means it is also empty set. Here let us go to this symbol, this symbol before introducing another. This symbol is known as epsilon. This means that A is an element of set A, that is A is a member of set A. We read is A belongs to set A. If I write in this way, it means A does not belongs to set A. For example, if I take natural number set 1, 2, 3 and so on, I can write 10 belongs to n. But minus 10 does not belongs to natural number. So this one is a epsilon symbol which read as belongs to. Now let us go to the another type of set. One we have studied empty set. Now another one is singleton set. Singleton set, by its name it is clear that singleton set will have only one element. For example, any set, a singleton set has only one element. Let A x such that x is even prime number. So as we know that there is only one even prime number, that is 2, so it will give you 2. In this way there are so many examples of singleton set. Now let us discuss some other types of sets. Finite set. From name it is clear that the number of elements in a finite set is a finite, means fixed. The number of elements are finite, means fixed, means countable. You can say countable. Similarly, you can say infinite set. The number of elements are infinite, or you can say uncountable. For example, n, natural number set, is infinite set in which we cannot count how many natural numbers are there. For the finite set, you can give any example, that example of a vowel A, E, I, O, U. Uh, After this, let us discuss one more point, that is cardinal number, or you can say order of a set. Cardinal number of a set is nothing but number of elements in that set. So cardinal number is number of elements in finite set. Finite set. For example, if I take set of vowels A, E, I, O, U, so cardinal number n of V is here 1, 2, 3, 4, 5. So in this way, this is all about our set. In our next video, we will discuss about the subsets, operation on a sets, and many more things related to the set. Thank you.